What's up everybody, welcome to another video and I hope you're ready to flex those brain muscles. In this video we're going to practice solving radical equations, so equations that have radicals like square roots, cube roots, etc., where there are variable expressions under those radicals. We're going to practice some examples like this. This is sort of an easier introductory example. We're going to work up to a little bit harder examples and hopefully you get a little bit more comfortable with this. We're going to even break down the steps for how you can approach solving these in general. So let's go ahead and get started. The first step for solving radical equations is always to isolate the radical. If there's more than one radical, which there is in some harder, more complicated examples, then you just pick one of them to isolate. But for now, we're just working with equations with one radical, so we're going to isolate that one radical, and we could do that by adding 11 to both sides of this equation and then dividing both sides by 3. So again, what I mean by isolate is we want to get this radical equals stuff, okay? So get the radical by itself, in this case on the left-hand side of the equation. So we can start by adding 11 to both sides of the equation. So this minus 11 and plus 11 are going to cancel, and we're going to be left with 3 times the square root of 2x plus 9 equals 4 plus 11, that is 15. Now, all we have to do is divide both sides of this equation by 3. 3 divided by 3 is 1. Those cancel. On the left-hand side here, we're left with just the radical. This is what I mean by isolate the radical. Square root of 2x plus 9. That's all we have on the left-hand side. And on the right-hand side, we have 15 divided by 3, which is 5. Okay? So now, once we've got the radical isolated, what we want to do is get rid of that radical. And how we do that, since this is a square root, is we're going to square both sides of the equation. If it were a cube root, we would cube both sides. If it were a fourth root, we would raise both sides to the fourth power, etc., right? The index of the radical, in this case that's 2, that's the power you always raise both sides of the equation to get rid of that radical. Hopefully that makes sense. So in this case, we are going to square both sides of the equation. Square root and square, so those cancel, they kind of cancel. We're going to talk about that in a second. We're left with 2x plus 9, okay, on the left-hand side. On the right-hand side, we have 5 squared, that's 25. Now we have a simple linear equation. In this case, we resulted in a linear equation. The next couple of examples, we're going to have quadratic equations that sort of pop out of these radical equations. So really now the next step is solve this resulting equation, which we can do by subtracting 9 minus 9 to both sides. That leaves us with 2x, right? Because plus 9 minus 9 cancels, equals 16, because 25 minus 9 gives us 16. Now let's draw a little arrow, because after dividing both sides by 2, we are going to get x equals 8. And we can go back and check our answer. 2 times 8 is 16, plus 9 is 25. The square root of 25 is 5. 3 times 5 is 15, minus 11 equals 4. So we do get a true statement. 8 satisfies this original equation. Therefore, 8 is a solution to this original equation, and that's the only solution. So our solution set is 8. X equals 8 is our solution set. And again, I want to point out this step here. When we squared both sides, square root and square are not perfect inverses of each other, right? So I'm going to talk about what exactly that means and the implications for that, and why we always have to check our answer when we're solving these radical equations. So let's talk about why it's always a good idea to check our solutions whenever we're solving these radical equations. And really the reason we have to do this is a result of squaring both sides of the equation, or really raising both sides to any even power. But for this video, we're just going to talk about square roots and cube roots. So when we square both sides of an equation, or again, raise it to any even power, doing this has the potential to introduce additional solutions, which we usually call extraneous solutions. Here are a couple of examples. We have this equation, square root of x equals -1. This equation has no real solution. There does not exist a real number that you can take the square root of and get -1, right? However, once we square both sides of this equation, we get this new equation, x equals 1, which does have a real solution. So in an effort to solve this equation, we squared both sides, we got a solution, but it turns out to not be a solution of the original equation. This is an extraneous solution, okay? Here's another example. Square root of x equals x minus 2. This equation has one real solution, 4, right? The square root of 4 is 2, 4 minus 2 is 2. We're good to go with 4. In an effort to solve this, let's say we square both sides. The radical is already isolated, right? So we could square both sides, we get to here. Now from here in practice, we would multiply this out, we would get everything to one side, set it equal to 0. But in doing that, we would get two solutions, 1 and 4. However, 1 does not work in our original equation because we get 1 equals negative 1, which is not a true statement. 1 does not satisfy the original equation, so we call 1 an extraneous solution. 4 is the only solution to this original equation. So hopefully you can see how squaring both sides of an equation has the potential to produce a new equation. But what will always be true is that if the original equation has any solutions, those solutions will always also be solutions to the resulting equation. So when we square both sides or raise it to any even power and get this resulting equation, finding all of the solutions to that resulting equation gives us all of the potential solutions to the original equation. All we have to do is go and check each of those solutions. But once we check them all, we throw out the ones that don't work, we keep the ones that work, and we have our solution set. We're good to go. So let's go ahead and jump into another couple of examples. All right, so let's look at this next example. And again, we're gonna start this the same way we're always gonna start, which is isolate this radical expression. We wanna get this by itself, which we can do actually in one step by just subtracting 4 from both sides of this equation. So if I subtract 4 from the left-hand side, subtract 4 from the right-hand side, 4 minus 4 is 0, those cancel out. So on the left-hand side, we're just left with square root of x plus 2. And on the right-hand side, we have x, and then we have that minus 4, okay? So now we already have the radical isolated in one step, exactly what we wanted, perfect. Now let's get rid of this square root. Since it is a square root, we are going to square both sides of the equation to get rid of it. So square, square, the square root and the square cancel. We're left with x plus 2 on the left-hand side, and on the right-hand side, we have this x minus 4 squared, which you can write out as x minus 4 times itself. So you can write out actually 2 of these x minus 4 terms, and then you can multiply them out, or FOIL, if that's your thing, FOIL them out to get to the next step. Just a reminder of what this means. Maybe you can multiply this out in your head and get to there. That's awesome if you can do that. If not, write it out like I have it written out and FOIL it out. Write out each step. There's no shame in doing that, especially if you're still learning this. So x times x, that gives us x squared. That's the first. The outer and the inner are going to combine and be like terms. We have x times negative 4, that's negative 4x. Then the inner is going to be negative 4 times x, that's another negative 4x. Those are going to combine to be negative 8x. And then our last is going to give us negative 4 times negative 4, which is positive 16. And now from here, we have a quadratic equation that we're going to solve. So you can use whatever method to solve this that you want. I'm going to get 0 on the left-hand side of the equation, which you're going to have to do anyway for pretty much all the methods. And I'm going to attempt to factor it and use the zero product property. So let's see if we can go ahead and do this. I'm going to subtract 2 from both sides. On the left-hand side now I just have x, and on the right-hand side I have x squared minus 8x plus 14, because 16 minus 2 gives me that 14. Now I just have to subtract x from both sides, and when I do that I have 0 on the left, which is exactly what I wanted, and on the right-hand side I have, let's see, negative 8x minus x, that's minus 9x plus 14. And now I'm going to attempt to factor this. I believe this is factorable, but you can always attempt to factor it, and if you can't figure it out, you can use a different method like the quadratic formula. Let's see, 2 numbers that multiply together to be 14. We have 14 and 1 and 7 and 2. I think those are the only 2 pairs that work. And I think 7 and 2 are going to work because minus 7 minus 2 gives us that negative 9. So minus 2 minus 7, and if that takes you a little bit longer, that's perfectly fine. Again, whatever method you want to use. So we have 2 potential solutions, okay? 2 potential solutions. 2, and 7. So let's go back and check each of these solutions to see if they're even solutions to the original equation at all, okay? So off to the side here, let's check. Okay, which one we want to check first? Let's just check x equals 2 first. When I plug in 2, what do I get? Well, 4 plus the square root of 2 plus 2 equals 2. We want to verify whether this is a true statement or not, right? So let's simplify. 4 plus the square root of 4 equals 2. Square root of 4 is 2. So 4 plus 2 equals 2. 6 equals 2. This is nonsense. 6 does not equal 2. So this is what we're talking about when we're talking about an extraneous solution. It's going to produce something that doesn't make any sense, like 6 equals 2. It's not a true statement. So x equals 2 does not work as a solution to the original equation. This is an extraneous solution. Let's put a big X through it, okay? So now let's check 7. Does 7 work? Well, let's see, 4 plus the square root of 7 plus 2 equals 7. This is 4 plus square root of 9 equals 7. 4 plus 3, and it's looking like this is going to work. 7 equals 7, that is a true statement. 7 satisfies the original equation. Therefore, 7 is a solution to the original equation. And in fact, 7 is the only solution to the original equation. All right, so before we continue, let's go ahead and summarize the steps that we take for solving radical equations. So the first step is always to isolate the radical. And then what we do is we get rid of that radical by raising both sides to some power. And that power, in fact, is equal to the index of the radical. So if it's a square root, we square both sides. Cube root, cube both sides, etc. That's how we get rid of the radical. In this video, I'm focusing on equations that involve one radical expression. If we have more than one, then after this step, we may still be left with a radical expression. If that is the case, we repeat steps 1 and 2. Isolate it and get rid of it. And we repeat that process until they're all gone. I'm going to make a separate video on those examples since they are tricky and they're going to take a while to get through. So continuing, we solve the resulting equation and then we check the potential solutions that we get from that resulting equation into the original equation to see which ones are actually solutions and which are extraneous. All right, so hopefully this gives you a good summary. Let's continue with the examples. So here's another example, this time involving a cube root, but the process is still the same. We're going to start by trying to isolate this radical expression. And we can do that by first subtracting 6 from both sides of this equation. Once we subtract 6, we get rid of that plus 6 there. And what we're left with is negative 4 times the cube root of 2x minus 5. And that equals 10 minus 6, which is 4. Now all we have to do is divide both sides of the equation by negative 4. That's going to get rid of this negative 4 out in front. And what we're going to be left with is just that radical expression, which is exactly what we want. We have cube root of 2x minus 5 equals 4 divided by negative 4, which is negative 1. Now that we have this radical expression isolated, we can get rid of that radical. And since it is a cube root, what we're going to do is cube both sides of this equation. Cube the left and the right hand side. And what that cube is going to do is get rid of that cube root. So we're just going to be left with the stuff under the radical, which is 2x minus 5 on the left hand side. And now we just have to cube negative 1. So negative 1 times itself is 1. Times itself again is negative 1. So it's actually still just negative 1 on the right hand side. Okay. Now we just have this simple linear equation to solve, which we can do in a couple steps. First, by adding 5 to both sides of the equation to get rid of this minus 5. So those cancel out. On the left-hand side, we just have 2x. And on the right-hand side, we have 4. And now if we just divide both sides of this equation by 2, those 2's cancel, and we get, let's draw a little arrow here, x equals 4 over 2, which is 2. Now, do we technically have to go back and check whether this is a solution to the original equation or not? Technically, no, because what did we do? We raised both sides of this equation to an odd power. Whenever we raise both sides of the equation to an odd power, there's no potential to produce extraneous solutions, right? We cannot fundamentally change the equation so that it has new solutions by cubing or raising to an odd power. We can only do that with even powers, square, fourth, sixth, etc. So technically, no, we don't have to check this. We can guarantee that this is a solution to the original equation and that in fact it's the only solution to the original equation, but you can still do it just for practice. Maybe it's good for you to just check every solution. It's really up to you. So let's do one last example. All right, so since this is the last example, what I encourage you to do is pause the video, pull out a pencil and paper, try this example on your own, then press play whenever you're done and you want to check your answer. So now I'm going to assume that you're done and you're just checking your answer. Good. Hopefully what you started with is isolating the radical expression by adding 4 to both sides of this equation. We're going to add 4 to the left and right. That's going to get rid of this -4 here. So all we're left with on the left-hand side is the radical, which is exactly what we wanted. And on the right-hand side, we have x plus 4. So now that we've isolated the radical expression, what we can do is get rid of this radical by squaring both sides. Since this is a square root, we can get rid of it by squaring. And that's going to get rid of it and leave us just with what's under the radical there, x plus 10. And that's going to be equal to x plus 4 times itself. So I'll write it out twice just to help remind people of what that square means. We cannot distribute this square, x squared plus 4 squared. No, no, no. Write it out. And now we can continue from here. When we multiply this out, or FOIL, if you want to think about it in terms of that acronym, what we're going to get is x squared plus 8x plus 16, okay? So now we have this quadratic equation. We can solve using whatever method we want, and that's going to give us potential solutions. Then we're going to go and check those solutions in the original equation. Hopefully you're getting the hang of this by now. So let's subtract 10 from both sides. We're left with x on the left-hand side. On the right-hand side, we have x squared plus 8x plus 6, because 16 minus 10 gives us 6. And now we can subtract x from both sides. And what we're going to get is 0 equals x squared plus 7x plus 6. Looks like this is factorable, so I'm going to attempt to do that. In fact, I think I see already what it factors into, which is, let's see, 6 and 1. Multiply together to give us 6 and add together to give us 7. So plus 6 plus 1. And what that gives us is 2 potential solutions, right? -6 and -1. So let's go back and check. We'll start with -6. Let's check x equals -6 into that original equation here. Well, what that's going to give us when we do that substitution is -6 plus 10 under the radical here, -4 equals -6. So let's see, -6 plus 10, that gives us 4. So square root of 4 minus 4 equals -6. The square root of 4 is 2. So 2 minus 4 equals -6, but 2 minus 4 is -2. And that does not equal -6. So this gives us a nonsense equation. -2 equals -6. That's a contradiction. So -6 does not work as a solution to the original equation. Let's circle that, put a big X through it. Nope, does not work. Put a big X through it. So now let's check our other solution, our other potential solution, which is x is -1. Does this work? Well, the square root of -1 plus 10 minus 4 equals -1. So let's see if this gives us a true statement. -1 plus 10 is 9. Square root of 9 minus 4. Okay, square root of 9 is 3. 3 minus 4, does that equal -1? It does. -1 equals -1. This gives us a true statement. So a solution that does work is -1, and that is the only solution to the original equation. Hopefully this video helped. If it did, make sure to hit like and subscribe. Leave any questions or comments below. But most importantly, Keep flexing those brain muscles, and I'll see y'all next time.